Good afternoon, class. We are looking at Module 3, covering chapters 5, 6, 7. Inverse trig functions is 6.3, and trigonometric equations and identities, also known as analytic trigonometry, chapter 7. Here's the second part. We are supposed to find the exact value of the expression. There's no need for a calculator. Sine 50 cosine 10 plus cosine 50 sine 10. We should recognize this as sine of alpha plus beta. Sine alpha cosine beta plus cosine alpha sine beta. So this is your alpha. This is your beta. That's the idea. So you add them up. You get sine of 60 degrees, and that's square root of 3 over 2. Sine of 165. You want to cut it into two pieces that both pieces are considered common arcs. You clearly can see that 165, for example, is the sum of 120 and 45. And now we use the same formula, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, which means sine of 120 cosine of 45 plus cosine of 120 sine of 45. And 120 degrees. The reference arc is 60 degrees because it's in the second quadrant, 180 minus 120, and that's 60 degrees. So this is the same as sine of 60 degrees because sine is positive in the first and second quadrant. This one is the same as cosine of 60, but in the second quadrant, cosine is negative, so this is minus cosine of 60 degrees. And so this is square root of 3 over 2, this is square root of 2 over 2, this becomes negative 1/2, this is square root of 2 over 2. Again, the denominator in both cases is 4, this is square root of 6, this is minus square root of 2, and that's the exact answer. No calculator. So a quick recap for this page. Simply put, sine of alpha plus beta is used. And this is indicating where the trigonometric functions are positive or negative. So in the first quadrant, all of them are positive. Second quadrant, sine is positive, which means also cosecant. Third one, tangent is positive, which means also cotangent. And the fourth one, cosine, is positive. That means also secant. So we want to prove the identity that ln of secant x plus tan x plus ln of secant x minus tan x equal to 0. So we start with one side, obviously the left-hand side, LHS. The left-hand side is more complicated. We use logarithmic properties. Ln of xy is ln x plus ln y. So we go this way by multiplying these two pieces. So ln of this expression, secant x plus tan x, times this expression, secant x minus tan x. So we are going from right to left. And this is a plus b, a minus b. And the result is a squared minus b squared. So the product of these two is a plus b, a minus b. The result is a squared, secant squared, minus b squared, tan squared. Now, I hope you see that if I move this way, this becomes 1. And ln of 1 is 0. Notice I keep the absolute value until the end. This you can drop it, and ln1 is 0. Sine theta plus cosine theta squared plus sine theta minus cosine theta squared equals 2. And of course, the left-hand side is the more complicated side. To square that, reminding you a plus b squared is a squared plus 2ab plus b squared. So sine squared plus 2 sine theta plus cosine squared theta. This is the same thing except you put a negative here. So negative. Clearly, these two cancel each other. So we have 2 of sine squared and 2 of cosine squared. And of course, the parenthesis is 1. Sine squared plus cosine squared is 1. So 2 times 1 is 2. Two cosine theta minus square root of 3 equal to 0. We're going to solve it between 0 and 2 pi. 2 pi. Also want to find the general solution. First and foremost, you move this. This becomes equal to this. And then you divide it by 2. It's a common arc between 0 and 2 pi. Theta is either pi over 6 or 11 pi over 6. Please understand, this is a common arc, and the reference arc is pi over 6. Cosine is positive in the first and the last quadrant. And over here, we put 2 pi minus pi over 6. And we end up with 11 pi over 6. So that's pretty straightforward. As far as the general solution is concerned, everybody, you just add 2k pi, or sometimes divided 2 in pi. It means the same thing, class. So 2k pi or 2 in pi, where n and k are integers. N or k are integers. That's the meaning of it. So pretty straightforward, everybody. Two cosine squared theta minus cosine theta minus 1 equal to 0. We're going to do the factoring. If need be, class, you can change this and say, let's say this is x. So you're looking at 2. So you're looking at 2 x squared minus x squared equals 0. And that's easy factoring, class. Two x and x, because 2 is a prime number, and negative 1, you have to have both of them, one of them negative. So you figure out where you put the positive, where you put the negative one. And in this case, it goes with positive here, negative one. Or you can directly factor it in this fashion. It's a matter of factoring. You figure out what's the fastest way for you. So either this one is 0, cosine theta is negative 1/2, or this one is 0, cosine theta equals 1. Now, for negative 1/2, I want to make sure you understand how you can come up with the answer fast. First, look at the concept of a reference arc. If you look at cosine theta equals positive 1/2, this is your reference arc, which is pi over 3. But because it's negative, negative takes place what? In the case of a cosine, in the second as well as the third quadrant. In the second quadrant, you say pi minus pi over 3. In the third quadrant, you say pi plus pi over 3. And of course, cosine theta equals 1 when theta is 0. Of course, it continues indefinitely, but remember, we stop at 2 pi. Again, pretty straightforward. Okay, so those are the answers. 0, 2 power 3, and 4 power 3. That's the set that represents the solution. Find the exact value of the expression and justify. Again, we don't want to use any calculators. First of all, we're going to put these two together. Remember, sine squared plus cosine squared equals 1. So 1 minus cosine squared is sine squared. So we know Pythagorean identities. Now we also know, if you look at a right triangle class, and this is 90 degrees, then these two must add up to 90 degrees, right? So A and B must add up to 90 degrees. So sine of A, if this is A, sine of A must be equal to cosine of B, because it's, for the sine is the opposite over the hypotenuse, for the cosine is the adjacent over the hypotenuse. Or we call them complementary angles. They add up to 90 degrees, or cofunctions. So cofunctions of complementary angles are equal. Sine of power 2 minus alpha and cosine alpha are the same. Cosine of power 2 minus alpha and sine of alpha are the same. Same thing works for tangent and cotangent. So if that is the case, what is this one cofunction with? 90 minus 20 becomes 70, or 90 minus 70 becomes 20, either way. So cosine of 70 is the same as sine of 90 minus 70. So you can keep this and change this to sine of 20. So sine squared of 20, they cancel each other, we end up with 0. So it's pretty straightforward, everybody. What about cosine 70, cosine 20 minus sine 70, sine 20? We recognize this as cosine of alpha plus beta, which is cosine alpha, cosine beta minus sine alpha, sine beta. So we call this alpha. We call this beta. So it's cosine of alpha plus beta, 70 plus 20. which is cosine of 90 degrees. And we should know cosine of 90 degrees is 0. Tan of 20 plus tan of 25 over 1 minus tan of 20, tan of 25. We recognize this as tan of alpha plus beta. Tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. So let's say this is alpha, this is beta. This makes it tan of 20 plus 25, which is 45. And tan of 45, we should know it's 1. And we are done. So things are pretty straightforward, everybody. Sine, we want to find the exact value. Sine of cosine inverse of 1/2 plus sine inverse of 3/5. So I want you to recognize this one as different arcs or angles. So let's give them a name, alpha and beta. If that's the case, we are looking for sine of alpha plus beta. To find sine of alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta, then if we have this, we have to find sine and cosine of both alpha and beta. Sine of alpha cosine beta, cosine alpha sine beta. We need those. So we start with this and we write cosine inverse of 1/2 is alpha. We gave it a name. By definition, it means cosine of alpha is 1/2. But remember, the inverse function, the limitation, we put it between 0 and pi, so it works out. And that means from the first and second quadrant. Now, this is 1/2, it's in the first quadrant. In the first quadrant, everything is positive, so we can easily find sine as well. This one, everybody, means sine of beta is 3/5. And sine, we limited between negative power 2 and power 2. That means the first and the fourth quadrant. Again, positive. That means quadrant 1. So both cases, we end up with quadrant 1, everybody. Which means everything is positive. So what do we have? Let's go back here. We have cosine. We want to find sine of alpha. Over here, we have sine. We want to find cosine alpha. And remember, sine squared plus cosine squared is 1. So what we have here is sine alpha cosine beta plus cosine alpha sine beta. We are using the first one. So we have cosine alpha. We have sine beta, but we want to find the other one. So let's go with sine squared plus cosine squared equals 1. So the first thing missing is sine alpha. So sine of alpha is, I hope you can see that this means sine theta, for example, is plus minus square root of 1 minus cosine squared. But we're going to go with the positive only because we said it's in the first quadrant. So following that, sine of alpha equals square root of 1 minus 1/4. This is cosine squared, everybody. 1/2 squared is 1/4. So you get 3/4. 3 remains, 4 comes out as 2. So that's pretty straightforward. Of course, if I want to find cosine, it works the same way. Cosine theta is plus minus the square root of 1 minus sine squared. And so we use the plus only because it's in the first quadrant. And so 1 minus, raise this one to the power of 2, you get 9 over 25. So 3 over 5 becomes 9 over 25. So 16 over 25 comes out as 450. So it's pretty straightforward. That means we are going to write all those four values. Sine of alpha, square root of 3 over 2. Cosine of alpha, 1/2. Sine of beta, 3/5. Cosine beta was found to be 4/5. Let's plug it in. Of course, the denominator is 10 in both cases. So this is 4 square root of 3. This is plus 3, and that's an exact answer. No calculators. So you should always go with the exact answer. And that shows your knowledge of various trigonometric identities. Establish identities where tan theta plus cosine theta over 1 plus sine theta is secant theta. We start from one side, and obviously the left-hand side, this side, is more complicated. So we change everything involving sine and cosine. This is fine. We change this one to sine over cosine. So we take a common denominator, which is simply the product of these two pieces. And when you take this common denominator, you multiply sine by 1 plus sine theta. You multiply those, you get sine theta plus sine squared. And you multiply those, you get cosine squared. So I hope no one has any problem with finding common denominators and things like that. It's very straightforward, everybody. Obviously, these two add up to 1. We replace. And so that means we can drop sine theta plus 1 and 1 plus sine theta are the same. These two we can drop them. So this becomes 1 over cosine theta. And 1 over cosine theta is secant theta. Knowing different identities, everybody. Sine of 3 theta over theta minus cosine 3 theta over cosine theta equals 2. We are going to start with the more complicated side, namely the left-hand side. Now, obviously, we have to take a common denominator when we have this case, and the common denominator is the product of these two. So sine and cosine, that would be the denominator. And this is sine 3 theta times cosine theta, goes to the numerator, minus sine theta times cosine 3 theta, goes to the numerator. So we just use the LCD sine theta cosine theta, and we add up two fractions. What do we notice here? Sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. I hope you notice that it works that way, okay? So the numerator is sine of 3 theta minus theta, sine of alpha minus beta. The numerator is sine of alpha, 3 theta, minus beta, which is theta only. So that's pretty straightforward. And so what about the denominator? You should be able, now that I wrote the equation, you should be able to recognize that if sine of 2 alpha is 2 sine alpha cosine alpha, if I had a 2 here, would be sine of 2 alpha. So I put a 2 and 1/2 just to make a point. 2 and 1/2 cancel each other, but what's inside here is sine of 2 theta. What is this one? Same thing, sine of 2 theta. And therefore, we can cancel them. And 1 over 1/2 is 2. Again, we want to establish identity. We start from one side. The left-hand side seems to be more complicated. And there are two ways to do this. I'm going to quickly look at both ways. Number one, I can think of this as a squared minus b squared. Remember, 1 is 1 squared, 1 cubed, whatever you want it to be. So that becomes 1 minus cosine theta over 1 plus cosine theta. So you keep everything else intact. These two cancel each other. 1 minus 1 minus cosine theta. I hope you recognize this as minus 1 minus cosine theta. The final answer is negative cosine. This is simple enough. I want to quickly show you the second method because this may not come to your mind. All you have to do, take a common denominator right here, which is 1 minus cosine theta. So you change this to 1 minus cosine theta. And minus sine squared. That means minus this one. Minus 1 plus cosine squared. So again, this one and this negative one cancel each other. Let's just do that. These two cancel each other. And we put this one first because it's positive. And we factor the cosine out from the numerator. Get cosine theta times cosine theta minus 1. These two cancel each other, but remember, they are not identical. What are they? They're opposite. So they create a negative sign that becomes minus cosine theta. So that's pretty straightforward, everybody. How about this one? Sine theta plus cosine theta over sine theta minus cosine theta minus sine theta over cosine theta. We want to prove equals secant theta cosecant theta. We have to use one side, obviously. Again, the left-hand side has two fractions, and it seems to be more complicated. So what is the common denominator, the product of these two? Sine theta, cosine theta, or cosine theta, sine theta, makes no difference. So we multiply this one by cosine. We get sine theta cosine theta plus cosine squared. We multiply this one by sine theta. So let me just write it at top of it so you can see that. So over here, if I multiply this one by cosine, I get sine squared plus cosine squared. And if I multiply this one by sine, I get sine theta cosine theta minus sine squared. So we have a fraction where sine theta cosine theta is in the denominator. Numerator has sine squared plus cosine squared, and this negative will change this one into minus sine theta cosine theta plus sine squared. And so these two cancel each other. So what do you have? Sine squared and cosine squared, they add up to 1. We cut it into two fractions, 1 over cosine, 1 over sine, and 1 over cosine is secant, 1 over sine is cosecant, and that's the final proof. Establish the identity sine 4 theta is cosine theta times 4 sine theta minus 8 sine cube theta. I'm going to show you two ways. I'm going to start with the left-hand side and say sine of 4 theta. 4 theta is 2 times 2 theta. Okay. So imagine this is, for the sake of argument, let's say this is alpha. Sine of 2 alpha is 2 sine alpha cosine alpha. Of course, alpha is 2 theta here. So we have 2 sine 2 theta and then cosine 2 theta. Sine 2 theta is 2 sine theta cosine theta. That is obvious. But what is cosine 2 theta? There are 3 different ways. Cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. This is the one that is helpful, everybody. So one more time, number 2 remains. This one is clearly 2 sine theta cosine theta. There's nothing you can do to change it. But this has 3 different ways of writing. This is the writing that will eventually give you what you're looking for. And so you just write down 2 times 2, 4 sine theta, cosine theta, and I'm going to put the cosine theta in a different color for a simple reason. So I want cosine theta, I have it. But I want those, so I'm going to put the 4 sine theta inside. If I multiply now, I get what I want, 4 sine theta minus 8 sine cubed. That's why I'm using different colors to distinguish among what we need. And believe it or not, that's the proof, everybody. And we're done with that. As far as second method, you can start from the right-hand side and get to sine 4 theta. Ultimately, what you have to recognize is this means 2 times 2 theta. And you can think of 2 theta as alpha x beta. You know what I mean? So on the right side, we will factor the 4 sine theta out. And we rewrite them in this manner so we can separate the two pieces. This piece is 2 times 2 sine theta cosine theta. And again, we write that because we want it to be clear that this is sine of 2 alpha. This one is cosine of 2 alpha. And so imagine 2 theta, I get 2 times 2 theta. Imagine, just for the sake of argument, it's alpha. Then this becomes sine of 2 alpha. Sine of 2 alpha. What is alpha? 2 theta. So 2 times 2 theta, or sine of 4 theta. And believe it or not, that is the proof. In this case, I don't know which one is easier, going from left to right or from right to left. I thought I'd write both methods and you figure out what works best for you. Okay. Now, shortly, we're going to cover this product to sum and sum to product. They have the formulas that have here, and I want to quickly establish how we arrive at those formulas. So we know that these are the sum and difference formulas for sine, cosine, and so forth. And I'm giving them numbers so I can refer back and forth to them. So equation 3 and equation 4, if I rewrite them, again, there's nothing brand new here. You've seen this. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Cosine of alpha minus beta is the same thing with a plus sign in between. So I write those two equations, and if I take the top from the bottom, in other words, subtract equation 3 from equation 4. If I subtract this one from this one, these two cancel each other. This one minus this one becomes 2 of that. So I write, please understand that I want to go with the right-hand side first. This becomes, okay, this becomes this. Equation 4 minus equation 3. Okay, so equation 4, the right-hand side becomes this, and the left-hand side is cosine of alpha minus beta minus cosine of alpha plus beta. Now, if I divide both sides by 2, this goes away, and this becomes half of that, and this is the formula we have here. Sine alpha, sine beta is 1/2 cosine of alpha minus beta minus cosine of alpha plus beta. So we proved one of them, and you can try the other two in the same manner, or you can look up the lecture. If we add these two, then these two cancel each other. We get two of that. If we add these two and divide by two, we get one of those. So instead of subtracting, if we add them up, these two cancel out. We get two of those, this plus that. And because I'm dividing by two, I get cosine alpha, cosine beta. And that is this formula. If we do the first equation and the second equation, if we add these two cancel each other. We get two of that. Divided by two, we get this one, which is the last one, everybody. Sine of alpha, cosine beta. So we proved those three easily. That's the idea, everybody. The sum and difference formulas helped us to the product to sum. The sum to product works in the similar manner. So sine of alpha plus sine of beta is 2 sine alpha plus beta divided by 2 cosine alpha minus beta divided by 2. We are going to prove that. We are going to let alpha plus beta divided by 2 be something. For example, theta, alpha minus beta divided by 2 be something else. Can't be the same thing. For example, gamma. So the right-hand side is looking at 2 sine theta cosine gamma. We can go with x and y, 2 sine x cosine x. Now, remember, two sine theta cosine gamma. This is the one. If sine of alpha cosine beta is this, we can introduce a 1/2 and write this one, and we get the 2 remains, and we replace this one with 1/2 sine of, instead of alpha plus beta, we get theta plus gamma. These two cancel each other, everybody. And now if you replace the theta with alpha plus beta over 2 and gamma with alpha minus beta over 2, so that's the formula. What happens is that if you add these two, minus beta and beta cancel each other, you get 2 alpha over 2, okay? And that becomes alpha. In this case, when you subtract, you get 2 beta over 2, and you get sine of alpha plus sine beta, And that's a proof that sine of alpha plus sine beta is 2 sine alpha plus beta over 2 cosine alpha minus beta over 2. Again, although you're not responsible for the proof, if you can follow it, it helps remembering it, okay? So a couple of simple examples. We want to use the product to sum formula to fill in the blanks and identify it. Sine of 14x cosine of 6x is half of something plus sine of something else. And we basically use the formula. Which formula? We're going to use this one. Take a look at this formula. So we need alpha plus beta. We need alpha minus beta, where 14x is alpha, 6x is beta. Add them up, we get 20x. Subtract them, we get 8x. Now, when you answer it, in MOM, they may ask you to put the smaller one first or the larger one first. You want to follow that accordingly. So we get half of sine 20x plus sine 8x. Now express the sum to product, sine of 5 theta minus sine of 7 theta. We use this formula, sine of alpha minus sine of beta. So let's actually go with alpha here, beta here, and 2 sine alpha minus beta, cosine alpha plus beta, both of them divided by 2. So 2 sine of 5 theta minus 7 theta divided by 2. This one 5 theta plus 7 theta divided by 2. Now 5 minus 7, that's 2. And this is 12 divided by 2. This is minus, by the way. Now, I hope you know that sine of negative theta is minus sine theta because it's an odd function. So you get negative 2 sine theta cosine of 6 theta. So that's a brief, description of product to sum and sum to product formula. And then an extra example, if sine is given as 3/5 and it's in the same pi over 2 to power second quadrant, everybody. Find the exact value of sine 2 theta, cosine 2 theta, and let's see what we get. Of course, we know sine theta is 2 sine theta cosine theta, which means we need sine theta as well as cosine theta. Sine is given. What is cosine? Plus minus the square root of 1 minus sine squared. Replace the sine with 3 over 5. One minus that is 16 over 25. Which is plus minus 4 over 5. And we choose negative 4 over 5. Because of the quadrant. It's in quadrant 2. That's the reason. In quadrant 2, cosine is negative. So plug it in. 2 times 3/5 times negative 4/5. We get negative 24 over 25. We're done with that. Cosine 2 theta. You can write it in a number of ways. Any of them will do the job, class. I can use any of them, and since I have sine theta as well as cosine theta, it makes no difference. So if I go with cosine squared minus sine squared, cosine is negative 4 over 5 squared, and sine is a positive 3 over 5 squared. This gives me 16 over 25. This gives me 9 over 25. The difference is 7 over 25 as the final answer.